Factoring by groups. Factoring by groups are a special type of factoring. You can't factor them like you would a trinomial because it's not a trinomial. For example, you could have 4 terms or 6 terms or even 8 terms sometimes. So what you got to do is you have to break it up into pairs. So as you can see, we got 2 pairs on the first example here. And in this case, what you do is you look for common factors. So basically, the first 2 terms here have a 5 in common. And then I have an n cubed and an n squared. You can see that's an n squared goes into both evenly. So we take that out. And if I factor that from both, that leaves me with 5 times 4 gives me a 20, so there should be a 4 here. And then the n squared times another n would give me an n cubed, so I need an n there. Plus, now 5 times 5 will give me 25, so I need a 5 there, and then the n squared would go there if I were to multiply, so I don't need to add anything. And on the right side, I have a 4n plus 5 already. As you can see, I have that here. So all they have in common is a 1. So I'm going to put a 1 outside as a placeholder and write what's left, which is 4n plus 5. And as you can see, we have something in common again. And what we do is just factor the common factor again. So we get 4n plus 5. And if you were to remove those out of the way, you could see what's left over is the 5n squared, and then the positive 1 right there. And then we have a nice pair of binomials, which are not factorable because this is even. This is squared plus 1 does not factor. It's primes. This is prime. And that's all you can do with this example. Now moving on to the next example over here. In a similar fashion, I got 4 terms. We break it up into pairs, and right away you look for the common factor. Here, the only thing the first 2 have in common is an a square. So we take the a square out, and then left over we get 5 times a minus the 2. On the second part, you can see they have a 4 in common, so I'm going to put a positive 4 outside. So 4 times 5 will give me a 20, so I need a 5 here, times a, minus 4 times 2 would give me an 8, so I need a 2 here. Again, we got our common factors once more. We factor that one out, 5a minus 2, and eliminating out of the way leaves me with the desired other factors, which are going to be a squared plus 4. Again, this one is positive, so you cannot factor it as a sum of 2 squares on factor. So we have 5a minus 2 times a squared plus 4 as our only factors here. And let's try a couple more. As you can see, there is a pattern to this insanity. However, it's something you have to know in Algebra 2 or in Algebra 1. We need to learn how to factor by groups. It comes up now and then, especially in a test. Here we got 25p cubed minus 10p squared. Here we have a 5 in common, so we take out a 5, and we have a p squared in common. 5 times 5 is 25, and then of course we have a p here because 5 squared times p was p cubed, minus 5 times 2, I believe, 5 times 2, and the next term over here, 5p minus 2 is what we have here, so we don't need to factor anything other than a 1 because nothing else factors. There's nothing in common except the 1. So we write 5p minus 2, and as you can see, we got our common factors. Take that one out, or factor it out rather. 5p minus 2 multiply that by 5p squared plus 1. This is a 5, by the way. And we have our only factors. As you can see, this is probably going to be the same type. Again, look for the common factor. Sometimes you have to rearrange them a little bit. I don't believe these you have to do that. So let's finish this one off. Let's see. We have 5m times n minus 4m plus 15n minus 12. Again, I look for the common factor. Here we're going to have an m in common. Put that in there. And let me change colors real quick just to illustrate what's left. So we're going to take out the m. And then we leave 5n minus the 4. Over here, what they have in common is a 3. 15 divided by 3 gives me a 5. So if I take out a 3, that gives me 3 times 5n and minus 3 times 4. So this should be a 4 over here. 3 times 4 is 12. So what are our common factors? As you can see, you take out the common. Let me change colors again, so just so kind of looks a little different. We will have 5n minus 4. Removing those out of the way leaves us with m plus 3. And then we have our factors here, 2 prime factors. You can't factor this any further. So these are your basic types of problems that you will see when you do factoring by groups. And of course, remember, it takes lots of practice. So the only way to get better at this is not by watching videos. Well, you do need to watch the video to see how to do it, but then you have to go and practice some more. There is no way out of that.